we shall prove this statement 1 plus 2, that is the sum of n natural numbers, is n into n plus 1 by 2. Okay. So how we shall prove this by induction? If you see the what is the first rule of induction? First we assume let Pn be the statement. Let us assume let Pn be the given statement. Let Pn be the statement, this mathematical statement, that 1 plus 2 plus 3 up till n is equal to n into n plus 1 by 2. Let us say this is our statement. Okay. I have named this statement. This equation I have named. What is the name of this equation? It is Pn.
PM.
Okay. Now the first condition is that P1 is true. Now let us check whether P1 is true. Let us see whether both the conditions are satisfied or not. Okay. For the first one, P1 is true. For n is equal to 1. Let's say what happens. For n is equal to 1. For n is equal to 1, on the left hand side, how many terms you should take? You should take only one. Only one term you should take, because n we are taking n is equal to 1. That means only one term. What should be your RHS? 1 into 1 plus 1 by 2, which is also 1, right?
Yes, sir.
This shows, since LHS is equal to RHS, since LHS is equal to RHS, therefore P1 is true. Or we also say Pn is true for n is equal to 1. Okay. You can either say P1 is true or you can say Pn is true for n is equal to 1. Because on the left hand side also you're getting 1. On the right hand side also you're getting 1. Left hand side is equal to right hand side for n is equal to 1. Now look at the second part of the statement. The second part of the statement says that Pm plus 1 is true whenever Pm is assumed to be true. So let us assume Pm to be true, where of course I have forgotten to write here, where m is a natural number. Okay. So let us assume Pm to be true. So we assume Pm, we assume this mathematical statement 1 plus 2 plus up till m is equal to m into m plus 1 by 2. We assume this statement. And assuming this statement, what do we have to show? We have to show that Pm plus 1 is true. Okay. So let's see what Pm plus 1 is. What do we need to show? We need to show that Pm plus 1. What is the statement Pm plus 1? If Pm is this, then Pm plus 1 should be one term extra.
M plus 1.
And instead of m, I will replace by m plus 1.
Hmm.
Right? We want to prove this. We will assume
Yes, sir.
this and we shall prove this. Okay. We are going to assume this and we are going to prove this. So let's see,
Okay, sir.
assuming this, how do we prove? And this is the main part. Okay. So if your sum carries 4 marks, for only for proving P1, you will get 1 mark. And the rest 3 marks will be this. This is the main thing. So whenever this sum is given, you always start from Pm. So we have, which sum, what is that we have assumed here? We have assumed Pm, right? So we start with Pm. So we have okay. Now if you see, we have to prove this statement Pm plus 1. Do you have m plus 1 here? So what you do here is you add m plus 1 to both sides. We add m plus 1 to both sides. What do we get? 1 plus 2 plus 3 plus till m plus m
M
plus
plus
1.
1.
M into m plus 1 by 2 plus m plus 1. Okay. So now have we got this one? See, you have got this one here, right?
Yes,
So we only
yes,
now
sir.
need to show that this part is your this part. Okay, so we need
Ah,
to take this to this. We need to show these two are the same. So we work only
yes,
with the
sir.
right hand side because left hand side we have already got same. We only need to work with the right hand side. So what you do here is you take m plus 1 common. If you take m plus 1 common, what are you left with? M by 2 plus 1. That means you get m plus 1 and you take LCM here. You get m plus 2 by 2. So what are you getting here? Half of m plus 1 into m plus 2. You can write it this in this way. Now remember m plus 1 is here and m plus 2 you can write as m plus 1 plus 1. So now
Yes, sir.
just check, have we got these two as the same?
Yes, sir.
That means now what have we done? We have assumed this statement. We started with this statement
Mm.
and we have proved this statement. That means
Therefore, PM is
this
true.
shows that this shows that Pm plus 1 is true. This shows that Pm plus 1 is true when whenever Pm is true for m belongs to set of natural numbers. Hence Pn, what is the statement? 1 plus 2 plus 3 up till n is equal to n into n plus 1 is true for all natural numbers. So that is what. And we are going to use the same technique over and over again. Okay. So let us see another problem here. Let me start fresh here. Let me do one examination problem here. This is a series kind of problem. Okay. Induction, you have 3 or 4 variations of problem that you normally get. Let us see another type of problem here, which is proof by induction that proof by induction. 1 by 1 into 2 plus 1 by 2 into 3 plus, and this continues till 1 by n plus 1, n into n plus 1 is equal to n by n plus 1. Okay, another series problem. Okay, so let us first assume, let Pn be the given statement. What is the given statement? 1 by 1 into 2 plus 1 by 2 into 3 plus up till 1 by n into n plus 1 is equal to n by n plus 1. Okay, be the given statement. Pn be the given statement. Now what we do is first you show P1 to be true for n is equal to 1. For n is equal to 1, what is the left hand side for n is equal to 1? Can you tell me what is the left hand side?
Sir.
We take only this one, right? The first term.
Yes, sir.
1 divided by 1 into 2, which is half. And what is the right hand side? Put n is equal to 1. 1 by 1 plus 1,
1 plus 1.
which is half. So you're getting, since LHS is equal to RHS, we say P1 is true, right? We now assume what? We now assume PM. So let us assume 1 by 1 into 2 plus 1 by 2 into 3, 1 by m into m plus 1 is equal to m by m plus 1. We assume this. Okay. Now what do we show assuming this? We need to show
PM plus 1.
this is pm we have assumed. Okay. We need to show pm plus 1. And what is pm plus 1? 1 by 1 into 2 plus 1 by 2 into 3 plus up till 1 by m into m plus 1 plus 1 by m plus 1 into m plus 1, right?
Yes, sir.
Is equal to m plus 1 by m plus 1 plus 1. That is what we need to show.
Yes, sir.
So assuming this statement, we are going to prove this statement. So we start from this statement, that we have assumed. So we have 1 by 1 into 2 plus 1 by 2 into 3 plus up till 1 by m into m plus 1 is equal to m by m plus 1. Now you see, we have to prove this one, right? In this one, you see, up till this we have in our PM only. This is the extra one, right? So what you do is you add this term to both sides. So adding 1 by m plus 1 into, let's write m plus 1 plus 1 as m plus 2 to both sides. We get 1 by 1 into 2 plus 1 by 2 into 3 till 1 by m plus 1, and you're adding this extra term 1 by m plus 1 into m plus 2, okay, is equal to m by m plus 1 plus 1 by m plus 1 into m plus 2. Now see, this side, left hand side, we have already got, right? Once we added this term,
Yes, sir.
we have already got the left hand side, right? The only thing that is we have not got is your right hand side, because we need to show that these two are same, right? So we work with the right hand side only. So how do you prove the right hand side? See that you have m plus 1 here and you have m plus 1 here. So you can take out 1 by m plus 1. You can take out 1 by m plus 1. If you take out 1 by m plus 1, what are you left with? You are left with simply m plus 1 by m plus 2, right?
Yes, sir.
And 1 by m plus 1. Now if you take the LCM here, you will get what? M square plus 2m plus 1 by m plus 2, isn't it? If you take the LCM, this is what you're going to get.
Yes, sir.
1 by m plus 1. Now this one in the numerator, m square plus 2m plus 1 is equal to what? M plus 1 whole square, right? And the denominator you have m plus 2. Now you see you have m plus 1 cancelled from here and 1 power cancels here. So what are you left with? You're only left with m plus 1 by m plus 2. So have we got now? Let's see. Here we had m plus 1. So we have got m plus 1. In the denominator we had m plus 1 plus 1. We have got m plus 2 here, right?
Yes, sir.
Isn't it? So we already got
Yes, sir.
m plus 1 by m plus 1 plus 1.
Plus 1.
So this shows that pm plus 1 is true This shows that Pm plus 1 is true whenever Pm is true. Okay, hence Pn is true for all n belongs to n. That's it. Okay, you can work out all your series problems in this manner. Okay, let me show you one with a factorial notation. Question here is, what time does this class end?
52, 30, sir.
Prove by induction. 1 into factorial 1. Factorial is written this way also, if you remember I told you. Plus 2 into factorial 2. Plus 3 into factorial 3. Plus up till n into factorial n is equal to factorial n plus 1 minus 1. Okay, for n belongs to n, you need to prove that this statement holds. So let us first assume, let Pn be the given statement. 1 into factorial 1 plus 2 into factorial 2, 3 into factorial 3 till n into factorial n is equal to factorial n plus 1 minus 1, where n belongs to n. This be the given statement. Okay, so let us now check whether P1 is true for n is equal to 1. What is the left hand side? Only one term we'll take, so 1 into factorial 1, which is 1 into 1, which is 1. What about the right hand side? Right hand side, put n is equal to 1, you get 1 plus 1 factorial minus 1, which is factorial 2 minus 1. And what is the value of factorial 2? It is 2. So 2 minus 1, which is 1. So since LHS is equal to RHS, P1 is true. Okay. Let us now assume PM. What is PM here? 1 into factorial 1, 2 into factorial 2, and so on up till n into m into factorial m is equal to factorial m plus 1 minus 1. Okay, for m belongs to n. So we have assumed PM. And what do we need to show? We need to show, or we need to prove that 1 into factorial 1 plus 2 into factorial 2 plus up till m into factorial m, and you have an additional term because of m plus 1. We need to show Pm plus 1, right? So m plus 1 factorial m plus 1 is equal to m plus 1 plus 1 minus 1. That is what you need to show. On the right hand side, m plus 1 plus 1 means what? Factorial means what? M plus 2 factorial actually. But for your understanding, I've given a bar and written. Okay. This is actually m plus 2. Understood?
Yes, sir.
So we start with, so we are assuming this and we need to prove this. So we start with this. So we have 1 into factorial 1, 2 factorial 2, up till m into factorial m is equal to factorial m plus 1 minus 1. Now, what do we need to do? If you see, we have to prove this, right? And till this part, you have already in PM. What is not there in PM? Only this term. So what we do, we add this term, adding m plus 1
To both side.
factorial m plus 1 to both sides. We get we get 1 into factorial 1, 2 into factorial 2, plus up till m into factorial m plus m plus 1 into factorial m plus 1 is equal to factorial m plus 1 minus 1 plus, because we are adding this extra term, m plus 1 factorial m plus 1, right? So now we have already got the left hand side. So we simply need to work with the right hand side. We need to prove, we need to show that this is the same as, we need to show that this is the same as this, right? Isn't it? You
Yes, sir. Yes.
understanding? Okay.
Yes, sir.
So let us now simplify this and show that these two are the same. How do you simplify? So you have factorial m plus 1, open the brackets, plus m plus 1 factorial m plus 1. Now you take the factorial m plus 1 together. Factorial m plus 1 plus m plus 1 factorial m plus 1 minus 1. Now you take factorial m plus 1 common, and you get 1 plus m plus 1 minus 1. So what are you getting? Factorial m plus 1 into m plus 2 minus 1, right? Now what is
Okay.
m plus 2 into m plus 1 factorial? Can you tell me? M plus 2 into m plus 1 factorial. If you remember, I had told you when doing properties of factorial that factorial n can be written as n into n minus 1 factorial, right?
Yes, sir.
So now, going by the same reasoning, m plus 2 into m plus 1 factorial can be written as m plus 2 into m plus 2 minus 1 factorial minus
Yes,
1.
sir.
Can you write it in this way?
Yes, sir.
Then what is it equal to? If factorial n is equal to n into n minus 1 factorial, then m plus 2 into m plus 2 minus 1 must be equal to m plus 2 factorial, right or wrong?
Couldn't get, sir.
Huh?
Didn't get, sir.
If
I
you take
didn't
this,
get that
if you
part.
take this as m plus 2, then this part is your m
Uh,
plus 1.
yes, sir. Yes, sir. Yes, sir.
That is why. So I've got m plus 2 factorial for this, and this minus 1 remains as it is. So now see, have I proved? You need to prove that you needed to prove that uh, on the right hand side you have m plus 1 plus 1. I have proved
Yes,
this
sir.
to be m plus 2, which can also be written as m plus 1
N plus 1 plus 1.
plus 1 minus 1. So that means pm plus 1 is true. Therefore, pm plus 1 is true whenever pm is true. Okay. Hence, pn is true for all and belongs to n. That's it. Okay. This completes all your series problems. Okay. Now
Yes, sir.
from I'll stop here for today.